In this video, I'm going to talk about Chapter 7, Integer Arithmetic. First, we're going to talk about shift and rotating instructions. There are two kinds of shifting, rotating instructions, logical shifting versus arithmetic shifting. When you do shifting, you can go shift left, shift right, shift arithmetic left, shift arithmetic right, rotating left, right, rotating carry left, rotating carry right, left, shift double left, double right. Okay, logical shifting. And shift each bit to the right one location. And here we have example. This is a byte. 1, 2, 3, 4, 5, 6, 7, 8 bytes. If we shift to the right, move each one to the right one location, and this one going to be here, this one be here, this one to be here, and this one will copy into carry flag, and this one will get off from the byte. The last one over here will be copied into second last, the bit 6. We have opening space at the last location, and if it's a logical shifting, and the opening new space will be filled up with 0. So this is a logical shifting, and position will be filled up with 0. For arithmetic shifting, if we do the same thing, shift to the right once, we copy all this to the right, and the old opening space here will be filled up with the sign bit. The original sign bit here is 1. So we're going to copy sign bit to the opening space here. So this is arithmetic shifting, and copy the sign bit for the opening space. A shift right, shift each bit to the left once. This one will get to the first place, and the original first one will copied into carry flag. There are new opening space here, and will be filled up with 0. Shift left is like multiply their number by 2. If you shift left once, you multiply it by 2. If you shift to left twice, you multiply the number by 4. So each time you shift to left once, you make the number value doubled. Take a look here. We have original 1 byte is 5, because this is 1 plus 4, so this is 5. If we shift this to the left once, and we copy this one to here, this one to here, this one to here, so this is that. This one will shift off. The new opening space will fill up with 0. If we add up this number, this is 2 plus 8, that's 10. So this proves this idea. Shift to the left once, you can make the number doubled. If you want to multiply a number by 4, that means you have to shift to left twice. That means 2 locations forward to the left. So if we have 5 in DL, we shift DL twice to the left. We're going to have DL to be 40, because 5 shift once is 10, and 10 shift once is 20. A shift right, okay, so it's going to, this is the logical shifting, copy 0 into the opening space. If we shift to the right logically, we can divide the number by 2. If we copy 80 into DL and we shift to right 1 bit location, and we get 40. If we shift right 2 bit location, continue from here, we're going to get 10, because if we shift 40 once, we get 20. If we shift 20 again, we get 10. Shift arithmetic left and shift arithmetic right. I shift arithmetic left is the same or identical to shift logical left. But shift arithmetic right is different from shift logical right. If we have negative 80 in the air, we shift right once. We had to do arithmetic shifting, and we get negative 40. And if we shift arithmetic right twice, we get negative 10. So this is a negative number, and we use arithmetic shifting. You want to prove this, you have to use two's complement format. First, you start with positive 80, then you convert into negative 80 by two's complement format, like we studied in chapter 1 or 2. From there, you can do shifting, and you can verify. If you shift right once arithmetically, it's going to be 40. If you continue shift 2 more locations to the right arithmetically, you're going to get negative 20. So this can be proved by using binary numbers in two's complement format. Okay, you can verify all this by yourself. The answer is here. Rotating. Rotate each bit to the left once. The most significant bit will rotate back to the end, their least significant bit location. So they're going to go through like a circle. It's a circulating right here. So no bits are lost. The highest bit is copied into the carry flag, also copy into the lowest bit. So this one copied to carry flag, also copied to the end the lowest bit. So this is an example. If you start with this number and you rotate the AR to the left once, that means this bit will copy into CF. Also, this bit will copy to the end to here. So the result will be 111. That means you have 3 left. Copy the 40, and with this one move to the end. So that's a rotate left. If you rotate 3F H to the left 4 times, that means this has a decimal digit will get back to the end of F, because each has a decimal digit represents 4 binaries. So if you shift 4 times, 1 has a decimal digit will be shifted to the end of rather, this is rotating. That means 3 will rotate back to after F, because you're shifting 4 bits there. Rotate right is going to rotate the least significant bit to back to the most significant bit location. Also, the lowest bit will copy back to the carry flag, and no bits are lost. So this is the same example like last one, but this one's going to rotate to the right. If you rotate this to the right once, least significant bit here will copy back to here. Also copy to CF. So the result is this. 3 0 plus 4 1, and first there will get to the back. Same idea here. If you rotate this hexadecimal to the right 4 times, this F will get off and go back before the 3. You see, each hexadecimal is 4 bits. So you shift 4 bits, you get 1 hexadecimal off to the front. Your turn, you can try this. Rotate the carry left. It's going to rotate through a carry flag. So if we rotate the left, this significant bit will be rotated into CF. Whatever is in CF is going to copy it back to the lowest bit. In this example, we have CLC. CLC is an instruction. This instruction is going to clear the carry flag, so set CF to be 0. Then start BL with 88. This is 8, another 8. You're going to rotate the carry the left. So this is before the rotate left. And this one will get into carry. And whatever is in carry is going to copy back to the end. So just move all this to the left 1 position, and this one rotate back to here. So this is the result. If you rotate the carry left 1 more time, that means you copy all this to the front once, and this carry flag will copy back to the least significant bit. Rotate the carry the right. The least significant bit will copy into CF. Whatever is in CF will be copied back to the significant bit. STC is an instruction. This is going to set the carry flag to be 1. So we start the carry with 1 and AH with 10. 10 means 0, 0, 0, 1, 0, 0, 0, 0. So we're going to rotate through carry to the right. So this is the beginning, and the least significant bit will rotate to carry. So this one will copy into carry, and all this will move forward once. You can see. Shift left double. This is a special instruction. For this instruction, you need 3 operands: destination, source, and count. So you're going to shift the destination to the left or the right based on the count, maybe 4 bits or 5 bits. Whatever is missing, the missing bits will be supplied by using the source. The second operand is the source. Here, this is the example. We're going to copy AL with this, BL with this. This is AL and this is BL. AL is the destination, BL is the source. And we're going to shift AL to the left once. So shift this to the left once. And this one will get off, copy into CF, and all this move forward once. The new opening space will copy from the source. From source, the most significant bit. So this is the shift left double. Shift left double example. We have WV variable. 9B86H, we have AX AC36H. We're going to shift W value to the left 4 bits. That means one has a decimal digit. And AX will be the source. So we're going to shift this 4 bits. One of this will get off. So we have BA6 left over. We have an opening space. Opening space will use the most significant bit from AX. So that's their answer. Their AX will stay the same before after the shifting because the source won't be affected by the shifting instruction. I shift double, right? So same idea, 3 operands. If the shift to the right, you put the destination, then followed by the source. You move if you want to shift right once, and this one get off. This 7 bits will move forward one location. A new opening space will use the least significant bit of source, that's BL. So one copy into here. Another example, so suppose you want to shift AX to the right 4 times, that means you're going to shift 1 hexadecimal digit off from the right side. So if you shift AX to the right 4 location 4 times, B will get off. You have 2, 3, 4 left over. The new opening space will be supplied by DX. That's 4. Same thing, source won't change before after the shifting. I'll try this on yourself. So this is the shifting instructions. Thank you for watching.